So now that we've got the basics for straight chain and branch chain alkanes down, what we're going to do is combine it together to actually create a priority on how to actually name a structure. So we'll go through right now how to name an alkane overall then, including branches. So the first thing you're going to do is we need a parent structure, and that's where that base chain name comes in. So you're going to count essentially the longest chain. The next thing you're going to do is find the functional groups. And for this naming, it's just going to be the branched alkanes. But we can see later when we get into naming that the functional groups can change depending on the atom arrangement. Next, we're going to prioritize them. Now, I've provided a list in your notes on the priority levels for the functional groups. For the alkanes, it's much more straightforward, and we'll talk about that in a sec. Functional groups. Once we prioritize the functional groups, from the chain we either need to start from the left side of the chain or the right side of the chain. And so once we determine which one is the highest priority functional group, whichever side is closest to that carbon on that side is going to start the number 1. And we'll get an example of that in a sec. And then essentially what we're going to do is locate each functional group with respect to that number 1 carbon that we've chosen, and we're going to then write out the names of everything based off of that. So let's try, for example, this compound. We're going to try to find the base parent chain. The longest chain, continuous chain, is what we're looking for. So if we look here, we can go up to 5 and then to 6. We could have gone up the way, it's fine. Either way, it ends up being the same. Left over then, so what we're doing is we're determining that this is our parent chain. And this is not actually part of the parent chain, and this now becomes a side group. So when we're naming, what we want to do is we're going to actually number everything from, since this becomes the number 1 functional group on here, this carbon becomes the number 1 carbon, and we're going to rewrite everything on this because of that. So this becomes the number 1 carbon. This is 2, 3, 4, 5, 6. The functional group left over is a methyl group, and the methyl group happens to be in the 2 position. So we write first the base chain name. It's the easiest way to start. I'm going to call this hexane, and I know that I have a methyl group. I also know that the methyl group is in the 2 position. Now I want to combine this information together and make it into one complete name. And in order to do that, I'm going to call it a 2-methyl, so the functional group ends up coming first, and it's typically in alphabetical order as well. And then no space, I'm going to write hexane, so 2-methyl hexane. We'll try out another example. The first thing we want to do is we want to get the longest continuous carbon chain. So if we look and just go straight across, we have 1, 2, 3, 4, 5, 6 carbons in a straight chain. But we want the longest straight chain. If we actually go 1, 2, 3, 4, 5, 6, 7 up this way, this constitutes the longest straight chain. And now this becomes the side group. And it can change depending on your perspective and looking at it, but you always want the longest carbon chain. So the longest carbon chain in this case is 7 carbons. We can call this heptane. The side group is an ethyl group. And we now need to determine what number position that is at. So if we take a look, we're going to count from the one side. If I go 1, 2, 3, 4 carbons in, that's where the ethyl group is. If I start from here, 1, 2, 3, 4 carbons in. Either way, it doesn't matter which way we go. It's always going to be on the 4 position. So we're going to call this a 4-ethyl. So remember, if it had been on the 3 carbon, this would have been a 3-ethyl instead. And we would have chosen the numbering system based on the closest carbon to that one. So to combine this all together, I'm going to have a 4-ethyl heptane. Try another example out, similar to the last one. We're going to look for the longest carbon chain, and I'm not going to guess this one. We know that this is the longest carbon chain. If we take a look at it, 1, 2, 3, 4, 5, 6, 7, 8. So we know right off the bat that we have an octane. Now we want to kind of circle everything and figure out what's left over. Now we can see that we have a group here left over, another group, 1 carbon each, so that's a methyl. And here we've got a 3 carbon chain, so we have a propyl group left over. In order to prioritize this, we're trying to see which side the substituents are closest to, which side the functional groups are closest to. And the methyl happens to be closer, it looks like, to this carbon. So we're going to call this carbon the number 1 carbon, just as we had started originally. If the methyl group or the propyl group had been closer to the other side at the number 8, if it had, say, been on the number 7 carbon, we could have named it that way. If you find that the substituents are there's an equal substituent on either side, then move to the next substituent inside to actually figure out which side has got the numbering associated with it. So I know I have a methyl group here. I have a methyl group here, and I have a propyl group here. From the numbering, I know that the methyl in this case is in the 2 position. I have a methyl in the 1, 2, 3, 4, 5 position here, and the propyl is in the 1, 2, 3, 4 position. So I have a 4 propyl. Now to write this out properly, we don't use the 2 methyls one after the other, 2 methyl, 5 methyl in the naming. We're going to use a suffix called dimethyl. So we're going to say that we've got a 2,5 dimethyl. So that is the combination of those 2 functionalities. It's dimethyl, not dimethyl. So now to name this, we're trying to combine the 2,5-dimethyl, the 5-propyl, and the octane together. The octane will come last, obviously. Now we have to decide which one of these 2 functional groups comes first. And it comes down to alphabetical order, and it's the functional group itself, the alphabetical of the functional group. So in this case, there's a P for the propyl, and it's not a dimethyl, it's the functional group is a methyl. So it's the alphabetical of the M and the P. So the M comes first. So to write this out, we would say it's a 2,5-dimethyl. Put a dash there. 4-propyl. And now, no space, octane. And that is the full IUPAC name for this compound. Try another example. If we take a look, we have 1, 2, 3, 4, 5, 6, 7 carbons. We have a heptane molecule. From the heptane molecule, we have a methyl and another methyl group. We have 2 of them, so we're going to have a dimethyl. And then we need to number the carbons as well. So the tendency is for people to always start here and end up calling this the number 1 carbon, but what we want to do is actually start with the substituent closest to an N carbon, and this methyl group fits the bill. So technically, when we actually do the naming, we're going to call this a 1, 2, 3, 4, 5, 6, 7. We want to start this side with the number 1. We always want the lowest numbers when we're dealing with IUPAC naming. So that tells us then that we have a methyl group in the 2 position, and we have another methyl group in the 5 position. So to name this overall, we would call this a 2,5-dimethyl heptane.